I'm going to talk about and show you some demos of how you can use CSS3, 2D, 3D graphics and animation in conjunction with a little bit of JavaScript and a little bit of jQuery to create hybrid HTML5 applications that you can deploy on Android devices and Google Glass. So how many people here are mainly or exclusively Android developers? Okay, not that many. So the other people, HTML5 sort of hybrid. So what do the rest of you do? iOS. Oh, really? Ah, well, I do have some good news. The new second pre-release for Xcode 5 and iOS 7 now supports tablets. I just found out that today, so I'm going to be downloading it soon. And the stuff that I'm doing, you can run on, you can use PhoneGap to create these apps for iOS devices as well. Just that for today, it's more, we'll be talking about how it pertains to Glass. And so how many people feel comfortable with CSS3, that sort of stuff? Okay, a few, so for a lot of you, it's new. All right. Well, I'm going to start with the first thing that I deployed to Google Glass. So this is pure CSS3. How many of you have seen this before from a previous demo that I've done? No? Good. Okay, so obviously there's the animation part, and then there's the graphics, and then there's the actual construction of the cube. So the cube consists of three faces. There are div elements, where I'm doing some transforms, which I'll talk about in a minute. The graphics is linear gradients and radial gradients. And then the animation is based on something in CSS3 called a keyframe. Now, you know what a selector looks like. So a keyframe basically is a thing where inside you define things that look like selectors, but they're based on percentages from 0 to 100. And in each one of those, you can put whatever stuff you want to put in there. So for example, in this one, let me see if I can get this without hosing it. So this is the keyframe. It's, as you can see, I just called it upper left. I actually have several in there. And then you can see at 0%, 10, 20, et cetera, et cetera. There are all these transforms. I'll get into some more details. There's matrix is kind of a generic type of transform, excuse me. And then there are the other ones that will create the effects. I'm a little bit discombobulated here with this, but okay. So this is the HTML page. As you can see, there's practically nothing there. There's a reference to this CSS style sheet, and then there's that outer div. Sorry. Just ignore that. That's the other demo. Sorry. So in CSS land, in 2D, there are 4 transforms. Rotate, scale, skew, and translate. Now, in 3D, you can actually sort of create the counterparts in 3 of the 4 cases. There's no skew, but there's rotate, scale, and translate. And basically, the advantage of the having 3D transforms in CSS is that you can use the GPU, and that's where all the power that you get from your device. And in order to ensure that and guarantee that you're going to actually invoke the GPU, there's a kind of a no-op that you can do, which is called translate 3D 000. If you don't have that, you still might be actually using the GPU, but you're not necessarily guaranteed that you will. So now that you know how to get the GPU working, you might think, well, it might, because of these things can be very compute intensive, you might actually drain the battery. Well, it turns out that you might be doing calculations, more calculations, but it's actually in less time. So for example, if you're using the GPU, it could be a 10-fold increase in speed, so it would drain the battery 10 times faster, but it's only in, say, 1/20th the time. So it's actually half what you would get if you're on without the GPU. Does that sort of make sense? So more stuff faster, in much less time for the calculation, so that way, otherwise you drain the battery, it'd be pointless to have the GPU. So another example, this is just frivolous fun. I was learning CSS at the time, so I always like dice. I don't gamble, but for some reason I just always end up doing something like this. Very similar effect as the first example. So, okay, now there's a limitation to what you can do with CSS3. There are some things that are more conducive to doing with a little bit of jQuery. How many people use jQuery? Great. So either jQuery or JavaScript. Here in this case, I used jQuery. So this actually works. Let me see if I'm not that good at it. Let me see if I can do it. I'm just showing you this. Originally, okay, got it. Anyway, this is CSS3. The paddles are divs. That bouncing ball is a div. So you set border radius to 50%. And there's a little kind of a clock tick, if you will, with set timeout. And then it just does a little bit of JavaScript to check if it's too far to the left or the right, and it reverses the order if it is, and likewise vertically. And so then when it checks for a collision. If it hits the paddle, then it adds a point. And if not, it checks if it hits the wall, and it bounces. That's basically it. The key point for this is that getting the collision, or getting the position rather, so that you can detect whether you're up, around the paddles. The way that I found that was best done for this, because all the stuff that I tried didn't work, it went on Stack Overflow, nothing worked. jQuery Mobile gives you exactly the position that you need whenever you're doing a touch event or a mouse event. So this works because of the fact that jQuery Mobile has virtualized the touch events and the mouse events. And those methods all have a V in front for virtualized. So this will work also on a tablet, and I have a phone as well that it works in the orientation. Originally I had it hard-coded just to get it to work, but then I was trying to get to port this to Google Glass, so then I had to handle the orientation, so that basically forced me to do the JavaScript, which I sort of hate doing, to get the orientation right and the resizing and all that stuff. So the first part's done. Now, getting it over to Google Glass, you can, in case I didn't already mention it, basically any Android APK can be ported to Google Glass. So this in an APK, port it there, fine. Now the question is, how do you handle the movement of the paddles? There's obviously no touch and no mouse. Voice isn't going to work. So I'll give you a hint. It's a sensor in Android. There are 13 of them.
Gyroscope.
What?
Gyroscope.
It might work. I haven't finished it yet, so we're in the process of doing it.
Accelerometer.
There you go. Why would the accelerometer work? Because with your head movement, when you're moving across, you can detect the change, and then get the data comes in, and then do the arithmetic adjustments, and then you figure out when you're lined up to the right, and the head movement up and down, so you can move the paddle on the left and the right. So if you see somebody doing this, they're probably not listening to you. So, oh, and by the way, there's copyright stuff, and I mentioned this in the other event. I think up until 10 years ago, Happy Birthday was actually under copyright. So every time you sang it, you actually broke the law. Now, there's a game that was done, 30 years ago? Similar to this. So this is like, it's on glass, so I've called it Gong, just to make sure we don't get into any copyright type stuff. So anyway, so this is kind of fun just to do in terms of a learning experience. And this isn't the primary purpose for Google Glass, of course, but it just shows you that there are ways to do things on Google Glass. The question, though, is what are the semantics of sort of touch or related type sort of functionality? There's voice-driven commands, but how do you handle something where you want to have some kind of a menu without verbal commands? Now, you could do something like some sort of movement where there's no, essentially the person's looking at a spot, and within a delta of that, they're essentially not moving. And then if it lasts a second, it's sort of, that could be like a long press kind of thing. But, I mean, you can interpret things any way you want, but is that really the way is that an intuitive way of what people would want that to mean? I don't think it's quite, even Google doesn't really have an answer in terms of figuring out the sort of the UI-related navigation sort of stuff, except for the voice commands. So one thing I wanted to, I can move around, right? I won't knock anything over. Okay. So back to the stuff about the transforms. You would think that sort of converting all of your 2D transforms to 3D transforms, you get the performance because you got the GPU, everything works fine, right? Should problem solved? Not quite, because there's reflow and repaint that happens all the time. And in fact, anytime you scroll, resize, change the DOM, you're always going to be doing essentially, potentially triggering a reflow, which then means you got to the browser has to recalculate the layout of all of your stuff. And then a repaint is when the colors and so forth have to also be calculated. And that happens when things like opacity, linear gradients, radial gradients, drop shadows, all the fun, good stuff can trigger a repaint, which is a result of a reflow. So I'm not going to get into the details. You can check Google and find articles if you get to that stage where you need to use or be concerned about performance with CSS3 related functionality. So the question is, why would you be using CSS3 or not instead of, say, Android or iOS? Any thoughts? Before you answer, you can do transforms in Android. The Android.graphics package has a matrix class, and that has those 4 transforms that I mentioned. You can also do some 3D effects in Android using, I'll give you a hint, it's a class that's in Android.hardware. Any ideas? Probably the same in iOS. There's a camera class. And with the camera class, what happens is that you can essentially, as you move the perspective, the point of view, you can then calculate coordinates like the X, Y, and Z coordinates. That class also has things like rotate and translate. So you could take that, the matrix, and then you could start moving around and getting some 3D effects with that. So it's possible in Android. I believe the same is true with iOS as well. However, the big difference, obviously, is that with CSS3, it's in the browser. It's not compiled code. You can modify it very easily, and you can train people who don't have a technical background to create those effects. Now, another point to keep in mind, in case you're interested or exploring, with CSS3, you can also define selectors that reference SVG files. Now, that gives you a lot of powerful functionality because CSS3 is very good for the graphics animation, but it's not designed for doing sort of arbitrary kind of shapes. You can do rectangles, ellipses, and triangles. You can get into some other kind of unusual shapes. But if you want to do like a chart, a 2D graph or a 3D graph, Bezier curves, sort of arbitrary polygons, you could do SVG. In an SVG, you could have a pure document. You can have an SVG document where you have a C data section. It's XML. So for character data, inside of that, you can have JavaScript. So you can programmatically, at runtime, dynamically create elements and append to the DOM, do all this kind of stuff. And so in an HTML page, you can have CSS3, you can have SVG, you can have Canvas. So with all of the graphics effects, 2D, 3D, and animation. So it all works together pretty much. If you can think of a scenario, you can probably do it. It's just a question of how much work it is. So if you're going to be working with creating HTML5-based hybrid applications, and it's the kind of use case, not first-person shooter, obviously, but some sort of scenario where you want to create some very nice, aesthetically appealing visual effects, you can do that with CSS3 fairly easily, even if you don't have a strong programming background. So just to kind of move along, I wanted to show you something. This has some jQuery in it, and let's see what it does. Is it moving? Oh, okay. So this was kind of the jQuery CSS method is your friend. It's fantastic because you can set all these properties, CSS properties. Now, in the earlier example when I showed you the bouncing ball, the one thing I didn't mention is that in order to change the location of an element, you need to set the top property, and it's a numeric value appended with px for pixels, that's the vertical, and then set the left property, that gives you the horizontal direction. So this one here is, they're all div elements. So what happened was, essentially I went through a loop, and I think there's 720 of them, and every 10th one I added an animation effect based on the keyframe that I defined in another CSS file. So just so you can think about that when you see that again. So this is a polar equation. It's called conchoid, whatever that means. Okay, so finally I want to show you this is the kitchen sink example. This is the one where I just sort of threw in everything. Linear, gradients, radial, 2D, 3D transforms, rotate, skew, perspective. I threw in stuff I didn't even know what it was. At that time, I basically didn't like CSS, but then I saw the graphics stuff and I drank the Kool-Aid, and that was about 2.5 years ago. And then it's like every time I saw CSS stuff, it's like, oh yeah, I like this. So there's like clipping and everything that it completely changed my way of thinking. I flipped the bit inside, basically. And so I'm still not that good at CSS, actually. But it's, if you want to get sort of more comfortable with it, one thing you have to do is learn the box model. It's very, very important. Otherwise, it's going to seem like this very sort of like tenuous foundation, and you kind of sort of hack at it and make it work, and then you're afraid to touch it because it might break something. That's how I used to write C++ code, so it's sort of the same haunted feeling sometimes. But if you get into that, learn the foundation part if you have to. That's what I recommend, and also understand the relationship between CSS and the box model and the DOM, how that kind of works, and it all works together. And you know what? It isn't rocket science. You can all learn this. So if I can do it, you can do it. So that's just a simple set of things that I did. Now I want to show you some other stuff that Adobe has done. Has anybody worked with OpenGL? Great. So for the rest of you, very briefly, quickly, simplified sort of a description. OpenGL is this pipeline-oriented architecture where the output of one stage is the input of another. Some of the things, it's very machine-friendly, not necessarily human-friendly, so the terminology can be a little bit confusing. For example, vertex shaders, those are the things that you use. The code looks like C, and it's actually the place where you apply kind of transforms to sets of points that represent triangles, which is the triangularization of an object. So these calculations are done. So that output is finished, and it goes to the next stage. Then it goes to the fragment shader, which may be intuitive for you. It's not for me. It's the place where the actual pixel values are calculated for each of the points in the transform set. That's OpenGL, kind of, sort of. So Adobe created something called shaders, and it essentially gives the power of sort of OpenGL in CSS, where you use a custom tag, and inside you specify a vertex shader, which by convention ends in VS, and then fragment shader by convention ends in FS. And so you get the power of all that stuff without doing any of that code. And if you've tried to do OpenGL or WebGL, you know how non-intuitive that stuff can be. There's a guy who, forgot his name, the guy who did the jellyfish. Has anyone seen the jellyfish example? It's done in WebGL. The guy wrote it entirely in WebGL. These floating jellyfishes, it's just a sine wave, he said, but I mean, it's all the other, that's the easiest part. All the other stuff that he created, the effects, so it's all this WebGL. He said, read the tutorials, learn the stuff, and then forget about doing it manually, use the libraries. So one of the things that you can do is, and they don't exist yet for Adobe, hopefully they'll come out soon, use the tools that they have. One is called a FilterFactor, which I'll show you the link. So just to give you an idea, I mean, this is kind of a basic thing. You can do that already, right? So with a hover, you can rotate this thing. It's not working perfectly. Now this is one, as you can see, vertex shader. It's kind of indicative of what it's using. Now take a look at that. This is, okay. Try doing that with Android or with iOS and getting it right quickly and easily. As you can see, this is the kind of stuff that you can do that makes the website of doing things a lot more fun, I think. My favorite, still, this one here. Oops, is this working? How well does it? It's kind of acting kind of weird here. Can you see that? Okay, that's CSS. So what they're using under the covers is they're using shaders and so forth, but I think what I saw was there's some Bezier curves that are involved. It's not super, when you're up close, you can see it's imperfect. The jaggies are there. So, don't be disappointed, now. But I mean, in terms of creating the effect itself, the code is actually fairly simple. And here's the, can you see that? The link at the top? That's where they have the, their, what do you call it? Their filter lab. So what you do is there's just a bunch of stuff that you set, and as you do this, it changes. Sorry about that, it's not showing up too well. But as you can see in the bottom, do you notice how it's changing the code? Okay, so all of these effects, all the things that you're tweaking up here, twiddling around, it automatically generates the code for you. And people have taken WebGL code and just slammed it in there, and it works both ways, apparently. So that's going to save you a tremendous amount of time. If you get the effect that you want, just take your code and take the code that you get there and paste it into your HTML page, and you're done. So that's the super whirlwind tour. And I just want to get back to a little bit of flip through some of these. OK, so the matrix, you saw the matrix method. It's every 2D CSS transform can be represented by a 3x3 matrix. The 3D transforms can be represented by a 4x4 matrix. So what happens, you saw the code before, there was the matrix thing, and then there was rotate and all that stuff. Basically what happens, my understanding, is that all the transforms are converted to their matrix form. All of those matrices, they have to be 4x4 in order for compatibility. So essentially the 3x3 has to be represented as a 4x4 so you can multiply them all together. The browser will then perform the computation so that there's one matrix for each one of those things. Obviously, it's not going to recompute every time. So this is a slight trick question. Which one renders faster? The one where it's got the one single matrix, or the one where there's all of the user-friendly names like rotate and scale and so forth? The keyword is renders. They render in the same amount of time because the only difference is the computation to get from the multiple, all these matrices, to the single matrix. So at the beginning, when there's a delay and so forth, users don't know what it is, right? That's where the delay is taking place. So that's where you're going to see some performance degradation, as well as also with the reflow and repaint in some cases. So now that's the form, as you can see. It doesn't go row-wise, it goes column-wise. So it goes A1, A2, A3, A4, A5, A6, and the bottom row is going to be 0, 0, 1. That's just the way this method works. So the identity matrix, how many people have worked with matrices? Okay, how many people enjoy working with matrices? Good. I'll buy you a beer later. It's been about 20 years since I've worked with them, but so this is the identity matrix. The bottom row is fixed. So 1 and 1, the diagonal is the key thing to remember. When you change the diagonal values, that's where the scaling takes place. If it's bigger than 1, it's bigger. If it's between 0 and 1, it's smaller. So, oops. So there's an example of what a matrix would look like if you're going to do some scaling. So the scale thing looks like this. Not so bad, right? For those of you who haven't worked with them. Skew, SK, so off on the X, the first row, and then down below the Y, that's where you get the skewing effect that you saw before. Not so bad. Translate, at the end there, pretty simple. So the rotate, unfortunately, is the one that's a little bit not so intuitive. Essentially, it involves calculating the sine and cosine of an angle. And I showed down below, it's the cosine of an angle and sine of an angle. So basically, that negative sign that you see there, if you move it down to the other side, the way it is right now, that's a rotating counterclockwise. That's positive. If you move the sign down below, it's going to rotate in the other direction, just in case you need to know. So I showed you that. Let me get through. Blah, blah. OK, so another thing in Android you can do, again, you don't need to do this. In the Android.graphics package I mentioned, there's the matrix class and there's the bitmap. So when you get a reference to something in your main.xml, there's a PNG somewhere, you get that bitmap, and then for that you take, instantiate get an instance of a matrix class and then apply a transform, whether it's scale or rotate and so forth. So you can create these effects as well. And then also with a camera class, get the 3D effects. And, okay, just, I don't know why I put this in exactly, but who's worked with spherical coordinates? Do the rest of you need to work with that? Probably not. Do you want me to go through it? Spherical coordinates under 2 minutes. Or should I skip it? It's up to you.
2 minutes, can't go wrong.
Okay. Let's see if I remember. Basically, there's two triangles. And in the plane, you've got, say, the x and y coordinates. And I'm calling the hypotenuse w. So it's like this. Here's my lame stuff. So this is x, this is y, and this is w. This angle is A. Now, by definition, the sine of an angle is this y over w. Just the definition. The cosine of this angle is this x over w. Just the definition. So you multiply both sides by w, and you get 1 and 2, right? Okay, so now take this triangle and put it in the plane, and then go x, y, and then z. So that's x, y, z. That's a point on a sphere, which by convention has a radius of r. So we have another triangle, right? The base is w, the height is z, hypotenuse is r. The angle is b. So once again, we'll have this triangle. So the sine of this angle b is z over r. The cosine of b is this, which is w over r. Once again, multiply both sides by r. And you get 3 and 4. Take equation number 4, where you got an expression for w, and substitute into 1 and 2, you'll get rid of w. And what do you get? You get the spherical coordinates of the point x, y, z in the Cartesian 3D plane based on the radius r of the sphere, which you obviously need. You need the angle in the plane, obviously, and then you need the elevation angle. That's it. So how long did that take? Since you wanted me to do it. Under 2 minutes. So that's the hardest part. Now spherical or cylindrical coordinates, what would you do? It's the same. So you have it in the circle, except z is unbounded, right? And then if you want to do helical, it's the x and y are the same, and then z is going to be the value of the angle, so it rotates in a spiral. That's it. I'd say it's pretty simple. So what are you going to do? Are you going to use spherical coordinates and all of the Android classes and methods and the camera class to do your stuff? Or if you're in a situation where it's feasible, are you going to use CSS3? I'd say the answer is pretty simple. If you want to be able to drink beer and be productive, I think the answer is clear. So with that in mind, the graphics that I did today, most of them are in that project. CSS3 graphics and Canvas and so on and so forth. And how are we doing on time? Okay, so give me a couple more minutes. And now I think this is the quasi-obligatory shameless plug. A few of the books that I'm working on. If you're interested in WebGL, I highly recommend Tony Parisi's book. He's the co-inventor of X3D and VRML. He's also the organizer of the WebGL group in San Francisco. And if you want to do more about CSS, I highly recommend Vincent Hardy. He's on the W3C specification for CSS3, very sharp guy, as is Tony. And also Tab Atkins for CSS. And if you want to do PhoneGap, Brian LaRue. We're sort of out of time. I didn't mention how to create the hybrid applications. I'm not sure. Are people interested in finding out how to use PhoneGap? Real brief. Yes? No? Sure? Okay. So here's what you do. To create those things, this is what I did with these examples. create an Android application in Eclipse or Android Studio. You got to do three things. First, there's this main.xml. That's the layout file. It's actually called activity_main these days with the newer versions. You got to replace the default contents with a web view, which is like 6 lines that you can get. Do a Google search. It's the same code. Just slam it in there. That's step 1. Step 2, go to the generated Java class, which is your main activity, which contains an onCreate method, which starts by invoking the super class, and then it gets a reference to that main class. And since it's a web view, we're sort of already on our way to what we need to do. After that, you got to put in like 6, 8 lines of code. Again, do a Google search. It's all related to an instance of a web view, and you set some parameters. They're kind of JavaScript-ish kind of things. And at the bottom, using file protocol, you specify an HTML page, which by convention, and this is the third step, go to the top of your project under the assets directory, create a www directory, and put all your stuff there. HTML, JavaScript, everything. There's sort of a fourth step. If you need to get internet access because you're going to a CDN, you need to give it internet permission and Android manifest.xml. But the coding part, those are the 3 steps. So then you just run and deploy, and you're done. So another point is that it doesn't just have to be HTML. You can specify an SVG file, which works for Android 4 or higher, pretty much all versions of iOS. And so why would you use PhoneGap? What I've described to you is sort of, there's no hardware access. If you want to get access to the camera and the accelerometer and the gyroscope and all of the sensors, you need something like, if you're not going to do it in pure Android or iOS, you need something like PhoneGap because it provides a JavaScript bridge that gives you the methods that access the hardware functionality. So what you can do, it's available on 6 platforms. So Android, iOS, Windows, BlackBerry, I don't remember all of the different platforms. And so you just install it, and then in iOS and Xcode, it shows up as an icon. So you just click on that and you start your project. If you're in Android, one way that's commonly done, from the command line, you run this shell script, it creates the project, and then in Eclipse or Android Studio, you import the project, and then copy it in, and then you're done. So that's PhoneGap. And I think that was sort of the end. Yes, it was. Anyway, thank you very much, and I'll hand it over.